Time travel is a fascinating and tantalizing idea. The notion that you could witness past events or have a glimpse into the future is something that sparks the imagination and challenges our scientific understanding of what time is. But is time travel pure fiction, or might it be achievable? History is full of time slip stories, such as the story of King Kakudmi in the Mahabharata, who travels with his daughter to the realm of Lord Brahma, returning in what feels like a few hours, but discover they have been gone for centuries. Similar tales include the tale of HaMe'agel, in which a Jewish miracle worker falls asleep beneath a young carob tree and awakes 70 years later, and the story of Japanese fisherman Urashima Taro, who spends several days at the Dragon Palace under the sea only to discover he had been gone for 100 years. But is any of this actually possible? In 1676, Danish astronomer Ole Romer proved that light travels at a finite speed, and therefore, when we look at the stars, they are a few hundred light years ahead of us. This idea would lead to many time travel theories involving traveling at light speed. However, time travel remained firmly in the realm of fiction and was the subject of many novels in the 1700s and 1800s, such as the time slip stories Looking Backwards by Edward Bellamy and The Sleeper Awakes by H.G. Wells. People start moving backward in time in stories in the late 1800s, such as the 1889 novel by Mark Twain, A Connecticut Yankee in King Arthur's Court. Eventually, authors indulged the idea their protagonists could control time travel, as seen in Edward Mitchell's The Clock That Went Backwards and Lewis Carroll's Sylvie and Bruno. In 1895, H.G. Wells published his famous novel The Time Machine. Perhaps inspired by current advances in automobile technology, Wells's book tells of a man who invents a machine that can travel through time at will. Around the same time Wells was writing what would become his most popular novel, a scientist was also attempting to explore time travel theories. Inventor Nikola Tesla firmly believed that time and space were not fixed and strived to uncover the secrets that would let humankind transcend the limitations of time. According to some sources, in 1895, Tesla discovered that magnetic fields could influence time and space. While Tesla's magnetic field experiments led to the development of our long-distance electrification system, there is no evidence that his experiments were directly related to time travel. Tesla's findings supposedly led to the alleged Philadelphia experiment in which a U.S. Navy ship named the Eldridge appeared to vanish and appear in another location before traveling back in time by several minutes. The story goes that the crew suffered horrific injuries, were driven insane, and some were found embedded into the steel hull of the ship. This event is said to have happened in October of 1943, 9 months after Tesla had died and the U.S. government had seized many documents relating to his work. In 1905, Einstein presented his theory of special relativity, which explains how speed affects time, mass, and space. In 1908, mathematician Hermann Minkowski expanded on this theory and proposed the idea of space-time, suggesting that in physical science, time and space are inseparable. After all, it is impossible to travel through space without also traveling through time. In 1915, 10 years after his work on special relativity, Einstein published his theory on general relativity, which explains the effect that gravity has on both space and time. According to these theories, objects with a large enough mass, such as planets, can warp the fabric of space and time. This warping manifests as gravity. So, according to this theory, the denser the object, the stronger the gravity, and the slower the time passes. This can be demonstrated by the fact that clocks at a higher altitude tick more slowly than those closer to sea level, and that clocks on spacecraft are set to tick faster or slower as needed to remain in sync with clocks on Earth. This theory led to a famous thought experiment called the twin paradox, in which one identical twin goes on a journey to space in a high-speed rocket while the other stays on Earth. The idea was that when the first twin returned to Earth, they would find their sibling had aged exponentially more than they had. In 2015, NASA had a chance to conduct a similar experiment in real life when astronaut Scott Kelly volunteered to go on a year-long space mission, leaving his twin brother, Mark, on Earth. Surprisingly, the study concluded that Scott may have aged slightly faster than Mark. But as Scott was not traveling anywhere near the speed of light and had to cope with the stress that prolonged space missions have on the human body, physicists do not feel that these findings may affect Einstein's theories. Einstein's theories caused a huge splash in the world of physics, and many other mathematicians and physicists used his equations to create their own theories. One such theory was black holes, a mathematical demonstration that should a star become sufficiently massive, it could collapse under its own gravity and become an object with a gravitational pull so strong that not even light could escape. In 1916, an Austrian physicist named Ludwig Flamm postulated the existence of white holes, a time reversal of black holes with nothing being able to enter, and hypothesized that the entrances to both black and white holes could be connected by a space-time conduit. In 1935, Einstein and fellow physicist Nathan Rosen proposed the idea of bridges connecting 2 points in spacetime. They called them Einstein-Rosen bridges, but they would later be renamed wormholes. While white holes remain purely theoretical, the first black hole was identified in 1972 by Louise Webster and Paul Merton. The movie Interstellar demonstrates the theory that black holes and wormholes could be the key to time travel. However, as all this is purely hypothetical, and as the nearest black hole is around 1,500 light-years away, the chances that we could ever actually utilize a wormhole to travel through time are pretty slim. Before 1949, physics suggested that while traveling into the future might be possible, assuming you could construct a craft that traveled faster than the speed of light, traveling into the past was theoretically impossible. In 1949, mathematician Kurt Gödel created the first mathematical model of the universe in which travel into the past would be theoretically possible. He worked with Einstein's general relativity framework, producing cosmological solutions that contained what he referred to as closed time-like curves. The idea was that there could be a curve in spacetime that would take a traveling object back to the very point in time and space where its journey began, essentially sending the object back into its own past. In time travel theory, Gödel's curves are known as causal loops, in which one event in the loop causes the next event, which eventually leads back to the beginning, reinitiating the loop. In reality, causal loops exist only in systems thinking, but they have become a common example of a time travel paradox. In this paradox, a future event causes a past event, which in turn causes the future event. One possible example of a causal loop is the 1985 story of the Dodleston Messages. Supposedly, a couple living in an old cottage in the English village of Dodleston received mysterious messages on a computer, messages that seemingly came from the past and future. The couple apparently communicated with a man from the 1500s and a being from the year 2109. While these claims have never been entirely debunked, most agree that it was a hoax concocted by the young couple. In 1991, a physicist named Richard Gott used mathematics to describe a scenario where two cosmic strings could be moved past each other in opposite directions to create closed time-like curves that would loop around the strings. The only issue with this theory is that cosmic strings are themselves hypothetical phenomena that have never been proven. While time travel has predominantly remained theoretical, in 1995, a 21-year-old electrician named Mike Markham claimed to have accidentally invented a time machine while trying to build a high-voltage traveling arc known as Jacob's Ladder. He claims that while trying to build the Jacob's Ladder, a vortex appeared above his machine. He threw a screw into the vortex, which disappeared momentarily before reappearing. However, his machine overloaded and caught fire before he could run any further tests. He decided to try building a larger machine and stole 6 old 300-pound transformers he found outside a power station in King City, Missouri. Once he turned his new machine on, the power surge caused a neighborhood blackout, and Markham was arrested for stealing the transformers. Upon his arrest, he reportedly told the police he was building a time machine. Markham was never able to produce a working time machine. However, several urban legends claim he traveled through time, ultimately leading to his demise. Despite Markham publicly denying that he was stuck in the past, rumors persist that his experiments were disastrously successful. In 2014, physicists studied the experimental simulation of closed time-like curves. Using an IBM quantum computer, the team succeeded in sending a simulated particle back in time by a millionth of a second. Despite the experiment being a success, the physicists pointed out that time reversing even one quantum particle is an insurmountable task for nature alone, meaning that you are pretty unlikely to stumble across a time portal, despite the many stories of time slips that have been reported. Modern theories on time travel involve the quantum realm rather than machines that can transport people and things through time. Some scientists have attempted to explain the phenomenon of non-locality through time travel. Non-locality of atomic particles is when a change in a particle's state can instantly influence another entangled particle that is in a different location. This effect has been demonstrated many times in numerous experiments and clearly causes a problem for those seeking to make sense of the world in which we live. One possible explanation that has been given for this effect is that it is not instantaneous, but that the effect travels into the future and then back to the past, making it only appear to be instantaneous. However, this interpretation has proved to be just as divisive and troublesome as non-locality itself. There are many issues with time traveling, such as the grandfather paradox, in which anything we change in the past could affect the future. The more pressing issue is, if you traveled in time, would you still be affected by the gravity of the Earth, or would the planet speed off at 66,627 miles per hour, leaving the time travelers stranded in space? Would time travelers have to account for where the Earth and the universe are at the time they want to travel, or would time travel be intrinsically linked to the planet they are on? Currently, it is generally agreed that it may be possible to travel forward in time, but not backward. Any hopeful time traveler would have to be content that the furthest back in time they could go would be the point that a successful time machine was switched on. Although scientists mostly agree that time travel could be potentially viable on a subatomic level, anything bigger would be challenging, to say the least. So while time travel may be fact in theory, for now it remains fiction, and we will just have to be content to travel slowly forward through time, occasionally being sucked into a time vortex of doom scrolling, only to be spat out at 3 a.m. How would you like to get a deeper understanding of history, impress your friends, and predict the future more accurately based on past events? If this sounds like something you might be into, then check out the brand new Captivating History Book Club by clicking the first link in the description. To learn more about Nikola Tesla's theories, check out our book, Nikola Tesla, A Captivating Guide to the Life of a Genius Inventor. It's available as an ebook, paperback, and audiobook. If you found the video captivating, please hit the like button and subscribe for more videos like this.